Hi, so in this video I'm going to show you how to apply the method for balancing the equations the easy way that I talked you through in the tutorial. Now I'm hoping you've read the notes that come with that and you've got an idea about what we're doing here and what the steps of the method are. But to be on the safe side, we'll just quickly recap. So these three rules that we're going to be applying are rules that go along with the usual rules for balancing equations. So remember, when balancing equations, you can't change the numbers in the formulae. You can only put numbers in front of the formulae, okay? Now, in addition to that, we're going to be doing these three things. So when you first look at your equation, have a look and see whether you have any polyatomic ions in there that appear on both sides of the equation. So for example, do you have a nitrate on the left and on the right as well? Now, if you do, you need to count it as one entity rather than counting the individual atoms. So you won't be counting how many nitrogens and oxygens you've got, for example. You'll just be counting how many nitrates you've got. Okay? And this will save you an awful lot of time because you'll have a lot less to count. And it will also save you a lot of confusion too. Okay? Now, the main part of our method, though, is that all we're going to be doing is working through the equation from left to right and changing everything that needs changing except the hydrogens and oxygens. Now, then, when we've been through the equation once doing that, we'll go back to the beginning, work through the equation again, and change everything that needs changing, but including the hydrogens and oxygens this time. Now, the reason we're doing it this way, remember, is because if you go in and change the hydrogens and oxygens straight away, you will find usually that you end up messing up the whole equation and you get it to the point where you can't really fix it. And that's where you end up getting stressed and panicky and thinking, oh, I can't balance equations, help, this is a nightmare. And it doesn't really need to be, but you just need to do things in the right order. So do everything but the hydrogens and oxygens first, then do the hydrogens and oxygens. And quite often, you'll find that if you do it that way, you don't even have much work to do the second time around, because often the hydrogens and oxygens follow everything else, okay? Now, I've got three examples for us to work through then, and it'll feel probably like we're going through these quite quickly, but that's sort of the point because we're trying to avoid the overthinking as much as possible the way that we're doing this here. So we're not going to be stopping and second guessing ourselves and worrying about whether we can make a change and whether it'll mess everything up. We're not going to do that. We're also not going to be writing down how many of each element we've got underneath it, because I often find that that causes more harm than good and it just ends up creating more work. Okay, so we're quite simply going to bash through the equation, change what needs changing, come back, do it all again if we need to. Okay. But before we do, we'll have a look at the polyatomic ions and we'll see whether we have any. So actually we do. We've got an SO3, which is the sulfite ion here, and the sulfite over on the right hand side as well. So we won't be counting sulfurs and oxygens, we'll be counting sulfites. Okay. So starting on the left hand side, it makes sense always to just start with the first element and go through in that order. We can see we've got one boron, but then on the right we've got two borons. So I need to make a change and put a 2 in front of the boron there to make that balance. Now onto the fluorine. I have 3 fluorine in the BF3, but since I've just put the 2 there, it will multiply everything after it in the formula. So that means I've actually got 6 fluorines, and it means I need 6 there. Okay, so boron and fluorine both now balanced. So onto lithium. Now I have 2 lithiums on the left hand side, but since I just put a 6 in front of the LiF, I've actually got 6 lithiums on the right hand side, so I need to put 3 there, and that will balance the lithiums. Now the 3 I've put here also then means I've now got 3 lots of the SO3. Now if I take a look at what's going on the right, I also have 3 lots of the SO3, and actually this equation is now balanced. So ordinarily I'd go back to the beginning and count everything up and make any more changes, but I don't need to because everything's balanced already. Okay? Now if you'd like to pause the video and just count this up for yourself, then go for it, but I'm quite happy with that. It's perfectly balanced, so I'm going to move on. Okay, now next example, we'll do the same thing. So I'll just check in for any polyatomic ions first. You can see I've got a PO4 and another PO4 there, so it appears as PO4 on both sides, and I'll be counting the number of PO4s, not the number of phosphoruses and oxygens. Okay. So starting on the left with the mercury, I've got 1 mercury there, but I've got 3 on the right, So I'm going to put 3 there. Now onto the oxygens and hydrogens. Remember, we're going to ignore these and we'll do those the second time around. Onto the phosphoric acid as well there. Again, I'm going to ignore the hydrogens there and I'll do those the second time around. So I'll have a look at the phosphates next. Now I've got 1 phosphate there, but 2 phosphates on the right hand side. So to balance, I need a 2 there. Okay. Right, so now I've got to the arrow. I need to come back to the beginning and I need to change anything that needs changing again, including the hydrogens and oxygens. Okay. So the mercury's fine, that's okay. On to the next one, oxygen there. Now actually the way that I do this, I usually balance the hydrogens before the oxygens because I just find it often works out easier that way. Every now and again, you might need to balance the oxygens first. And every now and again as well, it won't matter. So for this equation, it doesn't actually matter whether you go for hydrogens or oxygens first. But I like to stick to my method, and I find that doing hydrogens first usually works better, so I'm going to stick with that. Okay. So how many hydrogens do I have? Well, this 2 here means I've got 2 of everything inside the brackets, so I've got 2 hydrogens there. But the 3 at the beginning means I've got 3 of everything in this formula. So I've actually got 3 times 2 hydrogens, which means I've got 6 hydrogens there. I also have hydrogens though in the second compound here, and I need to remember to account for everything where this element appears. So you might find that the same element appears in 2 different compounds, and you've got to remember to count both of them. Okay? So I've got another 2 times 3 hydrogens there, which means I've got 6 hydrogens in total in this compound, and 6 hydrogens in this compound as well, which means I've got 12 hydrogens. So to balance, on the right hand side, I can put a 6 in front of the H2O, and that will give me the 12 hydrogens I need there as well. Now, back to the oxygens. So how many oxygens do I have? Well, again, I've got 2 times the OH, but 3 times everything. So that means that I've actually got 6 oxygens again. And if I go and have a look on the right-hand side, I've got 6 waters there, which actually gives me the 6 oxygens that I need. Okay. So this equation, again, it's fully balanced without too much work. A little bit more faff than the first one, but not too horrible at all, really. Now, just remember though, I did also have some oxygens in the phosphate, but we're not counting those as oxygens. We're counting them as phosphates. And that's where this is really helpful, because with this example here, we had enough oxygens to worry about without needing to count these as well. So we made it a lot easier by thinking about these as being phosphates rather than breaking it down. Okay. Now one more. Okay. So first of all, do I have polyatomic ions? Yes, I've got a phosphate there. And it appears over on the right hand side with hydrogen as well, but you know, that's a PO4, there's a PO4, so I can still just count these as phosphates. I've also got sulfates, so I've got an SO4 there, and it appears as an SO4 there too, so I won't be counting phosphorus and oxygen, or sulfur and oxygen, I'll be counting phosphate and sulfate. Okay? Right, so starting on the left, now I've got 3 calcium here, let's have a look on the right hand side. Slightly more difficult because the calcium appears in 2 places. So given that I need 3 calciums, and I've only got 2 at the minute, I can either put a 2 in front of the calcium sulfate, or I can put a 2 in front of this compound here. Now, you won't know necessarily what the right choice is going to be. It could end up being either of these that needs to be changed. So the rule that I always follow is that if I don't have really any idea about which one to balance, I go for the one that's going to make the less chaos elsewhere. So if I put a 2 in front of this calcium sulfate here, all it's going to affect is the calcium, which I actually wanted to balance anyway, so that's fine, and the sulfate. If I put a 2 in front of this compound here though, I'm affecting the calcium, which is fine, but the hydrogen and the phosphate as well. So I'm making more work for myself by changing this one. Okay. Now, going with the easiest example at least gives you the easiest option to start with. It might end up being incorrect. I might have to change this and come back and put the 2 over here instead, but I'm not going to go in there and make a difficult change unless I absolutely have to. I'm going to try it this way first. So sometimes with the balancing equations, you just have to have a bit of confidence to try things, and stick with your method though, because if you try things and stick with the method, you can't really make that much of a mess. if you try things, panic and drop your method, that's where you'll get in a mess. Okay. So I'm going to assume for now that the calcium will work like this. If it doesn't, I'll just change it. Okay. So going back over to the left of the equation, the next thing is the phosphate. So I have 2 phosphates on the left. I've got 2 phosphates on the right. So that's looking good so far. And moving forward, ignoring the hydrogens, I've got 1 sulfate. On the right hand side, I've got 2 sulfates because of the big 2 that I put there. So that means I need a 2 here, and that will balance the sulfates. Okay. So I've got to the arrow. I can go back to the start, and this is where I'll find out whether I made the right decision with the calcium in the first place. And let's see what we've got then. So I've got 3 calcium on the left, just checking in again. I've got 3 calciums on the right. That all looks fine so far. Onto the phosphate, 2 phosphate. Yep, the 2 phosphate's still fine. Now I include the hydrogen this time. So the hydrogen, we've got 2 times H2, which means I've got 4 hydrogens in total. On the right hand side, I've got 2 hydrogens, and then the little 2 outside of the bracket means I've got 2 times that. So I've actually got 4 hydrogens there as well, and that means my hydrogen's also balanced. So that's looking perfect. Just checking with the sulfate, 2 sulfates, we balanced that before so it should be fine, 2 sulfates there. Yeah. So actually we did make the right choice with where to put the 2 to balance the calciums, and everything else is balanced without too much stress. Okay. Now, these are all the examples that I want to show you because really I need you to go away and start practicing this method, and I need you to see for yourself how it works. Okay, so I've got a worksheet for you to try. Now you can download this from the link at the bottom of the tutorial. You can see actually that these are all quite challenging equations. You know, there's no point just practicing with the simple stuff. If you get an equation to balance in the exam, for the sake of balancing an equation, so marks are available for the balance, it's likely to be this sort of style equation. So I want you to practice your method with the horrible ones, and you might trip up a little bit, but if you stick with your method, you should find that by the time you get to this awful one at the end, you're pretty confident and you're pretty convinced that it's working. Okay, so best of luck with that.